In this video, we're going to find the population standard deviation of a data set. 3 friends grew water spinach plants and measured the plant heights after 30 days, rounded to the nearest centimeter. The tables below show the results for all 3 plots of land. So notice we have 3 different plots. The left column is the height in centimeters, rounded to the nearest centimeter, so these are whole numbers. And these are the number of plants that measured that height. So there were 2 plants in plot A that measured 48 centimeters, and similarly for plot B and C. So for question A, we're asked to find the standard deviation, and in this course we're going to always find the population standard deviation of the plant heights in plot B by hand using the table below, round to 2 decimal places as needed. Okay. So the data for plot B is up here, and it's really small, but this shows how you would put this in your chart. So finding a population standard deviation isn't really hard. It's just that it's a lot of steps, so you need to keep track of your computations as you go, and this is a good way to do so. Okay. So you put in the first column, you put your height in centimeters, so 46 through 54, and we'll need the frequencies in this row, so I put the frequencies here. Now the first step in general is to find the mean of the data set, and I've already done this for us, so this is step 1, is find the mean. Okay. Because step 2 is you need to find the difference from the mean of the data set and the mean, so you need the mean to do that. Okay. So in this column right here, we start with the data value minus the mean. Okay, and notice these values could be negative, and it's actually not going to matter in the long run. We're about to square them, so the square of any number, a negative or a positive, will be positive. Okay, but this is showing us something else as we go, and that is that this is 4 centimeters to the left of the mean, 3 to the left of the mean, 2 to the left of the mean. So this is giving us a relative idea of where these data values are compared to the mean. So the mean itself is 0 centimeters away from the mean. And I filled in the rest of the column, so you didn't have to watch me do this. If you want to write this in your notebook, you can pause it for a minute. So now that we have the difference from the mean of all the data values, we need to square the differences. That's the second step. So -4 squared, if you're going to put this in your calculator, you should put the -4 in parentheses, because remember this means -4 times -4, which is a positive 16. So -3 squared is positive 9, -2 squared is positive 4. And we have all whole numbers or integers, so this is pretty easy to find the squares. If you have decimal values, then you'll want to use your calculator, and also make sure you don't round any of your results till the end, because it can have a big effect on your final answer. So 3 squared is 9, and 4 squared is 16. Okay. So these are our squared differences from the mean, but now remember we also had more than one data point with each of these values, which is represented by the frequency. So to find the total squared differences, which is the next step, we have 2 data points with a square difference of 16, so we'll need to find, we could think of adding 16 twice, which is the same as 2 times 16. So basically in this next column, we're going to multiply the frequency by the squared difference, so we could find the total squared differences for each value. So 2 times 16, 4 times 9, 6 times 4, 8 times 1, 12 times 0, which is just 0, 8 times 1 is 8, 6 times 4 is 24, 4 times 9 is 36, and 16 times 2 is 32. So these are our total square differences. So our next step is we need to find the sum of the total square differences and divide by the total number of data points, which is the sum of the frequencies. Now if we add the frequencies, we have 4 and 6 is 10, and 10 is 20, 32, 42, 52. Again, you could do that on your calculator if you'd like, but we have a total of 52 data points. And now we'll add the total square differences to find the sum. 32 plus 36 plus 24 plus 8. We can skip adding 0 since it doesn't change it. 24, 36, and 32. And our total is 200. Okay. Now once we find these totals, we are almost ready to, or we're going to make our final computation, which we need to do on the calculator in one step. So our population standard deviation is equal to, you find the square root of the total sum squared of differences, which is 200, divided by the number of data points, which is 52. So we take 200. On this calculator, you'll do the division first, then the square root. On the multi-view, you'd hit the square root button and then do 200 divided by 52. So 200 divided by 52 is that. We're not going to round it all, never round till the end. And the square root to 2 decimal places is 1.96.